Okay, here's what I have of the Kapagen generator. 4 lamps in series with Mother Earth ground, but also connected between the lamps to ground. I have a 240 volt to 24 volt AC transformer going to a bridge rectifier, DC going back out all the way into the battery. And the voltages are jumping around from 0 to, see that, 15 volts. I don't know if it's because the caps discharge and the battery sucks it in and eventually accepts it, or what. But I started off at 13 volts, and the inverter is going to take up a little juice too, so nothing steady here. It's like a rhythmic thing here. Of course, the spark gap, maybe that could be finely tuned, I don't know, but see, now it's steady. It's 12.1 volts. And it jumps around again. See what happens here. The thing that gets hot here is the bridge rectifier gets hot. It's been running for about 3 or 4 minutes. Bridge rectifier gets hot. The ammeter is reading DC and AC amps somehow. It's staying about 6 amps on the output, but that could be radiant amps for all I know. I have no idea. Now, I know those bulbs are hot because that's just radiant energy. Oh yeah, they're hot. A great heater and a source of low light. And if it goes back to the battery, that'd be great because it's recovering maybe more than it needs. I don't know, but there's some heat loss here and here and here and here on the dimmer. The cap, cool. These caps, cool. They're not very hot at all, nothing. I had a microwave oven diode on there, but that thing got so damn hot, I had to take it off. I think I was losing power back in, recovering power back into the battery. I want to jump 2 batteries across there in parallel. So it's been running a good 5 to 6 minutes, and the voltages are jumping around. The power level on the inverter is at the first digit, so it's not even using much power. I mean, it's not even suffering at all. Something's got to give out here. I know it. Battery's cool. These are getting warm. Yeah, the leads are warm. It needs real thick wires. Wires have to be real thick to keep the heat down. But this is all heat, so it's, I don't know if it's stinky heat. You can't tell out here. This coil is cool. The ground is cool. The amps fluctuate 6 to a little bit above. Not much. The volts are fluctuating from 0 to 14 or 15 volts. Like that. It's like a dump. It's a capacitor discharge dump into the battery. And I don't know, an amp or two, because I watched the ammeter. Some kind of indication here. Oh, that went up to 9 or 10 amps there. So let's run in about 8-9 minutes. I'll let it run. Let's see what happens here. That could be put on a heat sink. The lamps fluctuate to low to high, and so does the voltage. The amps jumped up to 9 or 10 at one point there. I don't know if I'm conditioning the battery or ruining it. I don't believe that 6 amps out, but it's got the radiant energy bouncing all over between the coils and the transformer and the capacitors and all the wiring and through the battery. So, okay, it's been at least 10 minutes I've been running it. I'm going to sit for a while and observe. I hope this thing can be used like it is. And then heat sink that bridge rectifier, make it run cooler. The transformer really isn't that hot at this setting. I don't really care as long as it produces heat, light. And it's running at 60 hertz because of the inverter. There it goes again. It's stabilizing at 12, and it jumps. The thing here is the discharge can be sucked in by the battery and through the system. And the battery should be going dead, but it's not. It should be going dead. The gap is very small, less than a millimeter. Less than a millimeter. Amps are holding at, and these are radiant amps at 6 amps from at the battery going out, or coming in, or now going out. So I don't know. Let it run for half an hour here, and that's it. So I'm going to cut this.